As introduced, my name is Eric Reese. I'm a Senior Vice President with KIOXIA, but today I'm here as Chairman of the Software-Enabled Flash Project. And it's really exciting to be here, to be able to introduce Software-Enabled Flash to this crowd. Actually, some years ago, we made our inaugural presentation here to this group. And I really appreciate this group for the reason. One is you were the first to hear us, you were first to get excited about the concepts of software-enabled Flash. And also I really like this more intimate setting of people who are developers who are focused on storage. And with that, I want to continue on a little bit with the presentation. But some years ago, we, roughly 5 or so years ago, we had been doing a lot of research with hyperscalers, with other people about where does storage need to go? Particularly focused on the data center, where does it need to go? There had been lots of things going on in the market about standard drives working in the hyperscale environment. Why are hyperscalers building their own drives? And we'll just get used to the flicker here. You can think this is like the 1980s or something like that. Your old TV, you can bang it a little bit and make it go. But I introduced the concepts behind where we can go, and we got a lot of interaction. So if time allows, I'd like to repeat that and leave a little bit of time for some Q&A. But we'll see how that goes. Much ado about nothing. Today I want to do a couple things, talk about the Software-Enabled Flash project, the evolving landscape behind storage and why something like software-enabled Flash is necessary, how SEF changes the way things are used, who should be looking at it, why you should be looking at it, and what you can do to be involved since we're an open source project. So software-enabled Flash represents an evolution in software-defined storage and storage itself. And the reason why is because we're trying to bring the media, the software, the solid-state media to you, the developers. And therefore make what was something as a predefined function element into something that's software-definable. And with being software-definable, we bring different elements of control to you, the developer. That would include placement, latency, isolation, be able to prioritize your workloads, different software-defined protocols, and what's really important is actually a faster ability to migrate from one Flash node to another. Okay. Yeah. I do. Okay. All right. Yeah. I guess the problem with the BYOD, right? Okay. So a little bit about the project. Software-enabled Flash project is hosted and managed under the Linux Foundation. We're all familiar with the Linux Foundation, one of the gold standards out there in the marketplace. We're open source, and most importantly, I think in this particular effort, we're vendor neutral. So even though I work at KIOXIA, the project itself is vendor neutral and is open to all of you. And we'll talk a little bit about the end of the slide on how you can get more involved. Because it's open, we have a governance, I forgot I have a clicker here. We have governance processes and development process in places so that what is released is predictable. What is released has gone through a process so you can trust it. And we think that's very important. We oftentimes get asked about standards organizations. This, we believe, is one of the fastest ways to bring things to market. It's a predictable way, and by no means are we dissing or saying that standards organizations are not ideal. In fact, there's a history of projects moving into standards in the future, and that's something that we would definitely not oppose if that was the right thing to do. Of course, those who are members of the project would have to help decide that. Software-enabled flash is built for multiple implementations, meaning that it's not tied to a particular flash vendor, it's not tied to a particular controller manufacturer, it's open. I'm sorry. Finally, on the bottom left here, software development kits will be released as examples of how to do things. Command specs will be released. API is already out there on a GitHub. These things are, again, they're open. They're under, the source is going to be under BSD3 clause license, which is one of the most flexible licenses out there. If you go to the project site, you'll be able to link to the GitHub, and you'll find the API there and many other things coming quite soon. Just as a statement, I want to repeat time and again, we're vendor neutral. We follow all the antitrust laws. This is something your lawyers should have no problem with. Let me talk a little bit about the history of the project. So over the last 3 years, we've been releasing things on a nice and steady basis from year to year. But the history goes back before that. As I was saying in the introduction, we spent a good amount of time, the core members of the project, going and doing the market research with the future users, what we'd hope to be the future users of this technology. We spent a lot of time talking to the biggest names in hyperscale, presenting our ideas, getting feedback, and we had a nice feedback loop on that. And particularly the question is on your data centers, you're building drives. Why are you building drives? What is it you're trying to solve? Where do you see things needing to be in 5 years? Well, we're roughly at that 5-year period now. We've continued to bounce this information with those potential users, and we get a double thumbs up in terms of the directionality of this technology. It is what is needed. In 2020, I'm sorry, got some orange juice in my throat here. In 2020, we released the first concept on it as an FPGA to show what the API could do, what the technology platform could do. In 21, we released the first API as a reference, and that was a great reference tool. We got good feedback. Last year, we formally launched under the Linux Foundation as a project. And this year is going to be a great one because we've got hardware that demonstrates the API and all the concepts that we're doing. We'll have a reference SDK so you can get that thing up and going in your lab as easy as possible to be able to prove out the concepts of this and also to be able to get to further tune it to the needs of the market. So software-enabled flash is a union between hardware and software. We're not calling it software-defined flash because there's some things about flash that may not be necessarily definable, but we are enabling flash for control, particularly for behavioral control by the host. The hardware itself is purpose-built for this particular function. The software stack will give you the you developers control over placement, prioritization, over protocol use. These two are developed together to work seamlessly together. From the ground up. So this was something where from the beginning we wanted to have the hardware and the software to be able to be unified, and therefore we have attained that. And if you'll download and look at the API and then the command spec in the future, you'll see how that works, how the two work together in a beautiful heart of love. So I'd like to talk a little bit about the history, why this approach is necessary. Then we'll get into a little bit at a high level what it is. I'll make a pitch now, and I'll make a pitch later on in the slide. Scott Stetzer, who was introduced a little earlier, he'll be doing a technical track that'll go into a lot more about how this is done. I'm going to try to focus on the what it is and why it is. So The historical background to this is, as I mentioned, there were self-builds going on. Why was that? Well, at the core of that really is that flash and SSDs had to work in an environment where they had to behave as hard drives. And in doing that, there was a tremendous amount of benefit that was seen, obviously, and SSDs took off, and we see them as they are today. But to be able to continue to play in that field of the hard drive, I'll say, is paradigm, there are certain tricks that had to be, thank you. Certain tricks we've had to play with the flash to be able to make that work. And over time in its scale, that's led to some issues now that you need to see managed at the data center. And amongst those are latency, workload isolation, write amplification. Would have been nice if you'd opened it for me. All right, that's helped the dry throat there. Thank you. And I'd say primarily amongst those is actually to be able to keep flash in totality and the TCO factor competitive with hard drives. We need to be able to make it cheaper and cheaper, which means you have to pack in more density into that. And so transition from TLC to QLC from one version to the other has always been a real headache for you developers. So these are some of the things in the background of why we wanted to take an approach like software-enabled flash. Because of those issues that I've talked about now, there have been efforts within the industry over the past 5 or more years to address those. From the perspective of the project, these have been focused on more proximal issues such as write amplification and isolation. And I think the biggest reason for that is because those are economic factors in the data center. But as I mentioned, from our perspective, these are somewhat proximal rather than dealing with the core of the issue. With ZNS and FTP out there having probably the greatest level of attention right now, we see those as subsets of what SCF can offer. SCF is not trying to replace these at all. What we are trying to offer is a technological platform where you can build from these and then build up and have much more headroom. So with ZNS, you have one form of controlling isolation, gives you access to the internals of the flash. FTP is really focusing on write amplification with placement control. And as I said, these are elements that within the software-enabled flash technology, we give you control over these and more as more of a superset. So as I was hinting, the approach of SCF is different. You know, how do we treat those other things that we've just talked about, such as ENS and FTP as a superset approach? When we were studying what the ultimate storage device in the hyperscale environment needs to be, we realized that a lot of those issues that the hyperscalers were dealing with were in that list that I showed just a minute ago. They had to do with flash needing to work within a HDD paradigm. And so if we were able to change that paradigm, if we were able to look at the stack from the media up and take a media-focused approach, what is it about the media that you need to do to keep it healthy, to have it high-performing, to be able to last longer, and to be able to really excel and take advantage of the digital nature of the solid-state device itself? What needs to be done? And that's the approach that we take, and it's more holistic. It's looking up into the stack, into the pain points of the stack, and giving you ultimately choices through software enablement to be able to control the behavior of the device in the way that's going to work best within your environment. So let me talk about what some of those elements are that you can adjust and you can work with. First off, isolation. Isolation is really an important factor in all sorts of ways. It leads to write amplification factor, it leads to data security, it leads to all sorts of things. And so what we've wanted to do in software-enabled flash is to be able to give you that isolation, starting at a physical layer and then moving up into virtual layers. So within a SCF compliant drive, you'll be able to take that storage and divide it up into what we call virtual devices. A virtual device is more or less an isolation domain. And the only real limit to how many virtual devices you can create within a single SSD unit is really limited by just the number of die that's there. You can have you can have the whole drive be one virtual device down to as many as you need to make. Now, in our continued talking with customers, one thing that comes up right now with the higher and higher densities of SSDs is, is granularity. You know, perhaps one die, as dense as they are, is too much granularity. If you make a virtual device of some tens of dies or whatever else, you know, can you get the granularity you need? Well, with software-enabled flash, we wanted to be able to give that to you. So you can break each of these virtual devices into something called a quality of service domain. So where you have your physical isolation with a virtual device, you can then virtually isolate that down into subunits, what we call QoS domains, quality of service domains. So you can take that granularity and you can continue to dial it in as needed. So finally, isolation is something that's under your control, and you can dial it in as you need, and it's not predetermined by the drive manufacturer. Latency outcomes. Once SSDs began to be used at greater and greater scale, latency has become an issue. And oftentimes, there was a famous paper some years ago by Google called Latency at Scale, or something like that. It was a good paper anyway. But it was called The Tail at Scale, that's right. As we all know, SSDs have to do things to keep the flash healthy. And that, when you have large scales, can lead to unpredictability in your latency. And that obviously is something that's not desirable. Based on your workload, you may want to have a really low latency workload. You may have another one that doesn't really care. Obviously, the most important thing when you're at scale is predictability. So within software-enabled flash, we give you that ability to be able to have a predictable latency on a per I/O basis. Now, we give you different tools for being able to control that latency. Probably the best and most, I think, dynamic tool that we have that I'll talk about here, and Scott will talk about others in his technical thing, is what we call die time weighted fair queuing. So at die time weighted fair queuing, you can set your parameters for latency. And the best thing about the software-enabled approach is once you've done that to the API, your drives can then come in underneath that, whether it be a TLC drive, MLC, or QLC, and it'll still just work because the drives are now compliant with the API. So every time there's a new form of flash out there, you're not going to have to go out and rejigger your stack. Those generational changes are abstracted away. Now, we do offer other types of queuing in there, not just the die time weighted fair queuing. There's round robin, there's other ones. This on latency happens to be one of those that we think is the most exciting. Data placement control. This ties together also with isolation. I think many of you want to have like data kept together. You want to be able to write the like data together. There's also the I/O blender effect that you have on standard SSDs, where the data comes in, it gets mixed up, and then it gets written to whatever die are most available. With data placement control in SCF, you're able to isolate that, to break that down, to be able to place and write like data together in a way that is predictable and deterministic on your part. One thing that I'd like to add to this is data placement is also a big factor behind FTP. We have a virtualized FTP device on this, so if you have apps that are working with FTP, you don't need to necessarily modify an SCF drive to have that work. So we have some tools available to be able to have a compatibility factor for that. Again, I want to stress that we see this as a technology, SCF is a technology that is a platform, that is a superset that allow you to be able to take advantage of what's now and then have a future-proofing effect going forward. Data placement also is something that's really important in right amplification factor. And right amplification factor is something that I'm going to talk about now. If you are good about or careful about placing your data, you can reduce your right amplification factor as well as the amount of time that you need to garbage collect. There's a lot of attention right now on right amplification factor in the market or in the industry because of its effect on power consumption within the data center. The closer you can get your WAF to 1, the longer your drives last, the better the health of your flash. Also, the less power that you're consuming in the data center because you're not rewriting, you're not rewriting, you're not rewriting. Through the placement control that I've already talked about, the isolation control that I've talked about, an ability of you to be able to deterministically decide when your garbage collection is or isn't going to happen. These are all things that are in your control for you to be able to adjust, to be able to get the best right amplification you can get for your application. I would not say that there's a one size that fits all here. There's going to be different ways that you run your applications, that your companies are running their centers that would have maybe different parameters. And what we want to do is be able to give you those control over those parameters so you can dial that down as closely as possible to 1. And 1 is the loneliest number that you ever knew. Hey, I knew this is the crowd that would get that joke. What was that? I'm giving my own age away. Multi-protocol. Now, this is probably one of the ones that I think is one of the best shiny objects that we have within the SCF technology platform. Is that you have the ability to deploy different protocols. Now, Scott in his technical presentation is going to be showing a video of a demonstration that we have using, I didn't want to jiggle that cable, using this device. So these are the first hardware samples. We will be having others in the future as well in different form factors, but this is the first one that you'll be able to have access to. And using that, there's a demonstration that will really showcase this technology. Now, within that demonstration, you'll see that one drive is going to be running multiple protocols at the same time. It'll be running ZNS, it'll be running block, and each of those on its own virtual device, virtual domain that I talked about now, or even in some cases within a QoS domain, running a protocol independently. Now, I don't expect that any of you in your real deployments are going to have one drive doing multiple protocols at one time. But what we're trying to show is that the capability is there for you to be able to deploy a different protocol on a drive in the environment or pre-deployment according to your need via software. So servers oftentimes are expected to have a lifetime of up to 7 years. Your drives are not going to be performing the same as they do on day 1 to day, whatever 365 times 7 is. There's going to be degradation over time, and oftentimes because of that degradation, then the servers are future-proofed and overspec'd. This allows you, looking at the TCO advantage and other things, to be able to not have to so future-proof your servers with this SCF technology platform, because you can redeploy those drives under different protocols as needed. Do you need to have a read optimized or a write optimized or some other form of protocol that's going to fit the workload? Well, you can do that with SCF technology. You can change it. Now, in some ways, oftentimes with the firmware, if you have a drive that you're going to deploy in some form, and once you've deployed it in that particular protocol, it's set for life. Well, that's not the case. Well, you can make that not be the case with the SCF drives and the technology. It can be redeployed. And the great thing is the demo, we can see how you do that. So again, as your workloads change or as the flash degrades over time, you can redeploy that drive, you can use it. You can actually change the over provisioning as well on the fly to be able to best manage its lifetime. That also begs the question about what do we do about the housekeeping things that have to be done to be able to keep the flash as healthy as possible, your garbage collection, your wear leveling, things like that. These are all deterministically under your control. You can schedule these operations to meet the need of the workload that you have. Sometimes we're asked, well, what if I don't want to do it? What if I don't want to pause it for garbage collect? What if I don't want to do a wear leveling? Or if we don't do it, what if I don't know the right time and I get it wrong? What happens? We have in the firmware, within the API, the firmware of the drive will send out a signal to the host saying, you need to do some garbage collection soon. And you can set those timers a little bit. However, if you continue to abuse your drive, we won't let you drive it into the ground. Ultimately, it will override and do these functions, but you're going to have lots of warning ahead of time before it ever does that. So I don't expect that unless you are intentionally doing it, that you'll ever have that problem. Also, we do have advanced queuing protocols so that you can queue these housekeeping things up so that they can happen in a time where they don't interrupt the real-time protocols. Now, I want to talk a little bit about control for all you OCD types out there. I've talked about control a lot in here because that's the idea. Is we want to bring the flash to you, the developers. So we've gone through this concept of the SCF technology in as thoughtful and a way as possible. As I said, looking from the media up, what is it that what control is it that we need to give you, the developers, over the media to be able to get the best performance, to be able to extend the lifetime of the media, to be able to have you really harness the control of the flash itself being as wonderful a medium as it is. And I don't say that sarcastically. With the API, with this SCF API, we're going to be abstracting away the vendor differences. We're going to be abstracting away the generational differences. And we're going to be also abstracting away the different technological difference, being the bit density of that drive, so that if the drive is compliant and you've programmed to the API, from then on the drives will just work. And that's really the objective here, is that they're just going to work, because ultimately you'll have the control you need. How am I doing on time? Okay, what was that? We got 10 more? Okay, good. I was worried I wasn't going to maybe have too much time, but with our technical difficulties. So let me talk a little bit about the business side of things. We talked about the technological advantages. TCO is a big issue. Obviously, total cost of ownership is really where it's at. Particularly since I'm paid by a company that wants to sell media. We don't really want to be focusing on the price of the drive itself. I don't think that the other vendors are going to want to be focusing on that. We want to talk about what's the total value. So TCO is really the best, I think, way to look at this. When I talked about abstracting away the generational differences, I know that as I've talked with key people at hyperscalers, the number one competitive thing that they want to have is to be able to transition from one generation to the next as fast as possible. Obviously, the more bit density, the better it is for them. And so one issue that drive manufacturers have is when a new media comes out, you need to be able to do the testing and do all that stuff to be able to have that drive warrantable before it's deployed to a customer. There's not a whole lot that we as a project can do about that, but what we can do is make the transition as easy as possible for the developers, and also reduce the number of items that have to be tested ahead of time. And if the hyperscaler, if you are representing a data center and you've adopted this API, there's a lot of things that can be under your control that maybe you can be doing the testing on your side. As we've gone through this, we're very confident that software-enabled flash technology platform will not only ease on the development side the ability to go from one generation to the other, but I do expect to see some benefit on the qualification side as well. That saying, just want to make sure I hit everything here. From a usage point, from a TCO perspective, that ability to be able to abstract away these generational changes so you can just continue to deploy the newest technology as soon as possible really is, I think, the best TCO improvement that we as storage vendors can provide. A few slides back, I talked about the multi-protocol abilities of SEF, and this also has great TCO implications. One of the most proximal of that is the ability to buy an SEF compliant drive without a specific protocol to it. Once you brought that in, it reduces your SKUs. You can then, as the user of that, deploy it in whatever protocol is needed. So, no longer does in this future world, no longer would a purchasing agent have to be too concerned about over procuring one particular type of drive. They can procure this drive and then deploy it according to the needs that they have, and have an easier way to be able to move through that inventory. There's also great implications on TCO for the drives that you already have deployed. As we've talked about already, as the flash begins to age over time, you have the ability to adjust over provisioning as necessary. You can adjust the workload. If it's at a lifetime where a read optimized is the best for that drive, then you can begin to deploy that drive in that way. So to extending the lifetime, the health, we'd expect if you're following these good protocols that your drives will last longer than maybe a typical SSD would, and if not, you still have the ability to be able to eke the most out of that you can over its lifetime. Finally, on the virtual device side, within each of those virtual devices, I mentioned that you have QoS domains. The overhead provisioning that you can do, the over-provisioning control that you have, that would again lead to these economic benefits, can be done not only on the drive level, but at the virtual device level and also at the quality of service domain level. So, open source. I opened talking a little bit about why we decided to come to market first as an open source project. This is also, I think, something that has a great economic effect. Open source is actually right now receiving a lot of attention. It's receiving a lot more acceptance, particularly in the hyperscale world. And it also provides us a faster way to come to market, a faster way to bring the ecosystem together. There's not quite so many restrictions that you have in a typical fashion. And so this is the way that we've chosen to come to market, to be able to do this as quickly as possible in as open and vendor neutral way as possible. So, the Linux Foundation really provides a fantastic framework for doing that. We can be timely, open, vendor neutral, and I think the most important thing is it provides a structure that's both predictable and disciplined. And I think this preconception, I think, is getting dispelled now, but I think for a long time people looked at open source as the wild, wild west. Particularly in the framework under the Linux Foundation, that is not the case. We do have articles in place, systems in place, so that the process is predictable and dependable. Now, a lot of that happens within the TSCs, or the technical steering committees. These are held on a regular basis. We try to hold them multiple times a year. These are open to everybody. You don't need to be a member to be able to join the technical steering committee. We have one coming this Friday. I would encourage you to go to the website, register your name, you'll get an invitation. If you don't want to do that, just talk to Earl over here, raise your hand, or Sean over here. They'll be at the table. They'll take your name, they'll make sure that you're invited. If this Friday doesn't work, again, register your name on the website and we'll be sure that you're invited in the future. Again, as I said, you don't have to be a member to join and to participate. Your voice can be heard in that. It's the best place to be able to see what's going on with the project, what's coming down the road. And the TSC will have more information about when you can actually get hardware samples, when you can download the command spec, and when the SDK will be released. However, another call out to you old folks out, membership has privileges. Do you remember that one? Which credit card was that? Amex, that's right. I'm still using it. So with membership does come privileges. That is what comes through in the technical steering committees, what's going to be adopted, what's not going to be adopted. Paying members have the ability to vote on that. And so I would encourage you, we're open to new memberships. Vendors, controllers, anybody that is interested, flash vendors, controller vendors, please, and anybody else, consider joining, consider having a voice on what's going to be released. Again, we want to have these things be predictable. Let me wind this up. Thank you for being here. Thank you for listening to us continue to bring this new technology forward. We're at an exciting time where it's now with the ability being in your hands to test and to try. We got more information coming in this conference. The Birds of a Feather, not only will we be having Birds of a Feather, but we'll be feeding anybody who comes. Tomorrow at 2:30, Scott will be doing the technical show and tell, and we'll get a little bit more into how these things are done. If you want to get the code or read anything, please go to the website. You'll also find out about when the technical steering committees are going to be upcoming, and that's also where you'll find notices about when the SDK, the command spec, and other things will be available to you. How much time do we have left? Do you have any time at all? 3 minutes? Okay, so we got 3 minutes for Q&A. Anybody got a question? Yes?
What's the license on the open source code?
It's a BDS3. Mm-hmm. Oh, Scott, you wanted to... Oh, sorry. BSD3, okay, sorry.
Not BTS.
No, okay, BDS is something else bad, yeah. It's not dressed in leather. Any other questions? Yes?
I think you kind of touched on it, but the seal up this much control of your SSD, obviously a user can blow it up pretty quick. You said so your underlying code in your SSD is going to safeguard the SSD from wearing out particular dies faster than they're supposed to make sure that if you have to override, you will override so that from a warranty perspective.
Yes. Yeah, so compliant drives that come from any vendor we'll have to comply with the API. The API does require that the drive send you signals about, hey, you're beating me up, you need to do that. I've also got Kurt here, one of our engineers. Do you have anything you want to add to that in terms of making sure that somebody doesn't blow their drive up? No, really? Okay, I guess I got it.
So is it that you just send warnings, or do you send warnings and then
Actually, the drive will override and save itself. The drive will override it and save itself ultimately, but we trust that you will not force it to do so, because that'll hurt your latency. Any other questions?
Are you going to ship some reference implementations? For example, here's a read optimized profile, here's a write optimized profile, so we can see what, to get back to what with the drives we buy now and how you would do that with your software.
So yes, the SDK will come with reference implications. Implementations. So yes, the idea of the SDK being released with the hardware is so that people, when you put it on your bench, you can just fire it up and use it as quickly as possible without having to do your own coding. But you do have that, under this free license, you do have the source code, so you can muck around with it as you see fit once it gets going.
Any thoughts to management at scale?
Pardon me?
Any thoughts to management at scale and how to manage larger groups of them? Tool or mechanisms, or any thought put into that?
Management at scale. Boy, we could go on for a long time on that. What was that? Birds of a feather. Okay, yeah. Bring that question to birds of a feather. Looks like I'm out of time. But yes, there are lots of thoughts about that. And to not be acute, yes. There are ways, and we've talked with vendors on how this can be, I mean, not vendors, but with future adopters and how that can be done. And then to be serious, yes, do come to Birds of a Feather. We can give you more. With that, thank you very much. Appreciate your attention.